Our first lesson on C++ will be on how to make a simple program. In our case, we'll be creating a feet to meters converter. First of all, you're going to need a compiler. I will be using Microsoft Visual C++ 2010. Microsoft Visual C++ 2010 is a free integrated development environment, or IDE for short, which means you do not have to use an editor such as Notepad to type your code in and then put it into a compiler. It is a free compiler to download. If you do not already have it, then you could click on the link below to download it. If you already have a different IDE, feel free to use that as well. Alright, let's get started. We will want to begin by creating a new project. And for this purpose, we want to create a Win32 console application, which we will name Our First Program. You're going to want to make sure that you're creating an empty project without any precompiled headers. Next, we'll be creating a source file which all the code will be typed into. So right click, add, new item, C++ file, and name it main. Now we can finally start typing our code. First off, I want you to type / feet to meters converter. Anything followed by 2 forward slashes in C++ is disregarded by the compiler and can be used for writing comments. This is good to use as reminders of what your program is doing and what it is about. C++ is case sensitive. For example, return with a capital R and return with a lowercase r have two different meanings. However, it doesn't matter how many spaces are in between words and lines. In fact, it is good to have empty space in between lines to keep your code more organized. These spaces are referred to as white spaces. Alright, next we want to enter in this line of code, which consists of pound, include, bracket in, IO stream. This will be known as our header file. The pound symbol is the first thing the preprocessor looks for. When it finds it, it will modify the code as a command request. The include statement is literal and will tell the header to include whatever we will tell it to. In our case, this will be the IO stream, which simply means input-output stream, which is a part of the standard library. You don't have to be too concerned about libraries as far as right now. So we type IO stream and make sure they are within the brackets. So what this line of code does is tells the preprocessor to find the IO stream header file and include it in the program so that we can use objects such as cin and cout, which we will get to later. This way we do not have to type in the whole entire file. This line of code, no matter where you place it in your program, will be read off by the compiler before it executes the rest of the code. Next we need to include namespace. There are many different libraries which may have some of the same words as the ones you are using, and some of these words may have different meanings in different libraries. So which one does the compiler choose to use? Well, by adding the namespace, it automatically gives an additional name to your words so that the compiler knows which library to use. So, by adding the line using namespace standard, or std for short, followed by semicolon, it will make sure that all the words come from the standard library. Make sure to add the semicolon after this line of code. The semicolon tells the compiler that this is the end of the command. Certain lines of code do not need this ending statement, such as the main function. Our main function will consist of integer main, integer argument count, character, argument vector. This is a function that is automatically called when you start the program. Every program needs a main function. What follows integer main are called the arguments. Arguments are needed when you want your program to return a value. For the purpose of this lesson, we will not be going into arguments, for we will discuss them in a later lesson. Next line, we need to include a curly bracket. Everything within the brackets will be our statements, or what we wish the program to do. First off, I'm going to add a comment telling us what the following statements will be doing. This one will be telling us to enter the length in feet. First off, for this statement, we need to declare feet as a variable which may contain decimals. We could declare feet as simply as an integer, but then it will just round and give us inaccurate data. So we declare feet as float by typing float feet and end with a semicolon. Float means that it will allow the number to contain a fixed amount of decimals. This amount allows a pretty big number, so don't worry about this. So, this line states that feet is a number which can contain decimals. Next, we want to add a statement that will allow the program to display some sort of text so we know where to insert the amount of feet while running the program. In order to output text, we need to use the object cout. Cout simply means output. Followed by the object cout, we need to put two less than signs. This is known as the inserter. The inserter gives whatever follows it to the cout. In our case, we want it to be text. In order for us to make the text, we need to use quotations. Whatever we put inside the quotations will read on the program window when the program is running exactly as it's written in the program. So we want to add feet as our text, followed by a colon. Then we end the quotations and end the statement with a semicolon. Okay, so now we actually have to insert a statement that will allow us to insert the amount of feet. So in order to input anything into our program, we need to enter in the object cin, which simply means input. Followed by the cin is a reversed inserter, or two greater than symbols. After that, we want to put the word feet. Since we already defined feet as float, we need to spell it exactly how it is spelled on the line of code above. In our case, the variable feet is in all lowercase letters. So now, any number we insert into the program when it is running will be defined as the variable feet. And don't forget to close the statement with a semicolon. In our next set of statements, we are going to be converting feet into meters. So before we begin, I'm going to add that into a comment. First off, we're going to need to define meters. So once again, we want to use float, and this time define meters. So simply type float meters semicolon. Next, we want the program to calculate how many meters is equal to the amount of feet we enter. So in order for this to happen, we must set meters equal to feet times 0.3048, which is the conversion of feet to meters. So we type our variable meters and set it equals to by simply using the equals to symbol on the keyboard. Then we type in variable feet. And now we need to multiply by 0.3048. So in order to do this, we use the star as multiplication symbol in C++ and simply enter in our amount and end with a semicolon. So now whatever we enter as our variable for feet will automatically be converted into meters. Now we are going to want to see the results. So we're going to have to tell the program to output the results through the window when running the program. So before we write these statements, I'm going to add a comment, output results. And remember, we do not need to add comments for a program to run. They are simply optional reference points. So since I want to output the results of the equation we wrote above, we are going to need to use the cout object again. And don't forget the inserters. Followed by the inserters, we are going to want to put in quotations the word meters. Now remember, this is going to be the literal text that is displayed on the window when the program is running. Next, we are going to want them to output the actual results calculated from the equation we wrote above. So, put cout, inserter, variable meters. Now since we are going to pause the program so that it doesn't close right after we open it, we are going to use a command called system pause. which we will get to in the next few lines. But with that command, it automatically outputs the text, "Press any key to continue." We do not want this text to be displayed on the same line as our meters text because that will look messy. So in order to avoid that, we're going to add another set of inserters after the variable meters and add the command endl. Endl simply means end line. Next I'm going to add the comment wait to terminate. Followed by that, we are going to insert the command I was talking about earlier, system pause. This is a command that will automatically stop your program from closing until it displays its message on how to continue. We need this so that we can look at our results. Now this command doesn't really teach you much about coding in any way. It is more of a cheat command for beginners. So in later videos, I am going to show you different methods of how to pause your programs. Our final command is going to be the return command. And we are not going to return an integer with a value, so we type return 0. This goes along with the arguments in the main function, which I mentioned we will discuss in further tutorials. Finally, our last line of code is our closing curly bracket, which ends our statements. Now that we are all done coding, we want to build our program. So go to Debug, pull down the tab, and click Build Solution or press F7. If you follow this tutorial, then the build should be successful. Or if your build did have some errors in it and did not build successfully, go back and make sure that everything is spelled correctly and look for missing semicolons and things like that. Our last step is to test the program to make sure it is functioning correctly. So go up and find the Start Debugging button and click it, or simply click F5. Alright, let's enter an amount of feet and see what comes up. We enter 3, click enter, and the amount of meters equal to that amount of feet comes up, and the system pauses it, allowing us to review the results before we press a key to exit. So press any key to get rid of the program. Alright, let's open that program one more time. This time, let's see what happens when we type in a letter. We type in the letter A, click enter, and we get some crazy number. But why are we getting a number at all? Well, there appears to be an error in the program. So how do we fix it? Well, in lesson 2 we'll be discussing that. We'll be discussing how to fix it using if statements. So save the program now and wait for lesson 2 to come out so we can discuss this furthermore.